All right, so really what we're gonna do is correlation analysis, something that I've built a career around, actually. So, correlations are really looking at the statistical behavior between two random variables. And so, unlike last week, where we're only looking at one variable, here we're looking at the behavior of two variables. And I'll go ahead, it's not in the slides, but I'll write down the functional form of what that is so that it gives you a better idea, at least some framework to think about what R is doing in the background. But as I said, it's really two random variables, X and Y, okay? And what that relationship is. And correlation holds in no matter what context you want to use it in. But there's a big difference between statistical correlation and relationships and economic relationships. And we'll talk about that a little bit more. But really all correlation is saying, look, when X gets bigger, what happens to Y? And Y could get bigger, in which case they're positively correlated. But if Y gets smaller, then it's negatively correlated. Or they don't have any relationships at all, and if they're at the extreme version of no relationships, they're just independent from a statistical standpoint, meaning that X has nothing to do with Y and vice versa. Okay, and so here's just a stupid little graph of shoe size and height. So on the vertical axis is the person's height, and on the horizontal axis is the person's shoe size. Each of the dots represents an individual in my sample with their corresponding height. So we got a guy over 6 feet with his corresponding shoe size, which is a size 15. And if you look at that, it's trending up. And so in this case, the correlation would be greater than 0. And given kind of the trending up nature between the two, it's probably fairly strongly correlated. Now, we don't have a lot of observations here, and so, but out of the observations here, there's only really 4 that are not really following that general pattern of upward trending, and so more or less this is going to be, pretty positively correlated. One of the things that you want to be able to address is this question here. Does the person having a large shoe size mean that they're also tall? That it causes one to be tall? And probably not. And so we want to be very careful when we look at these relationships to not say that one causes the other. And I'm going to talk about something that I just looked at yesterday about the relationship between treasury yields and unemployment, and kind of show you what that would mean in that context. Okay, and saying vice versa here. Okay, so don't fall into this trap of making the causation argument. So you have both sign and magnitude. But the interesting thing about correlation is it's unitless and it's normalized to be between -1 and 1. There's another measure called covariance, which can be bigger than 1 or less than 1, -1. But in this case, correlations are being normalized so that they're between -1 and +1. And so, as it says, it's been normalized so there are no units. So in the case of inches and shoe size, it doesn't matter that one's in inches and one is in, whatever US shoe sizes. And so we see that the correlation becomes more positive, a stronger positive relationship, if you see that coefficient, that correlation coefficient is getting closer to 1, and that relationship, the correlation the relationship between the two variables is getting more inverse related or negatively related, the closer the correlation measure gets to -1. If you're right at 0, there's just no correlation going on. Okay. And that's kind of how we got both the sign and the magnitude, the strength. You know what I mean by magnitude? Magnitudes are doesn't matter if it's positive or negative, it's just how big that number is. So I throw away the negative sign. -10 has more magnitude than -1. That's what I'm kind of thinking about there when I say magnitude. All right, here's some examples of just how the correlations will look if I looked at a scatter plot. Again, this one has a downward trend. This one is all over the place, and this one has an upward trend. So this would be negative. In other words, the correlation coefficient would be below 0. This one would be close to 0, it would be positive or negative, but very close to 0. And this one would be positive, somewhere between 0 and 1. In fact, given how these dots are done, these are going to be very close to 1. Another example of something that's close to 0 in terms of the correlation, something that's going to be close to +1 in this case. And there's a bunch of examples of what that might look like, and these are the correlation measures on the top. So this is perfectly correlated, right? Negatively correlated. This is perfectly positively correlated over here on the far right. This is all independent, where there's no relationship whatsoever between the X and the Y, and then you get different versions of that. So most of the time, we're somewhere in these 3 cases in the middle and never see the ones on the far outside. The way that you calculate correlation in R is just to use the COR and the 2 variables that you're interested in. And they need to be numerical vectors. So if you put in a factor or something like 0-1 type of problem, that's going to create issues because you're not going to really have the right kind of variables measures for that. Okay. All right, so for the example that we've already had, shoe size and height, you just go ahead and use that as the 2 arguments. We can go and look at the FINRA data. Before I do that, I wanted to just write down, how many of you remember or were taught correlation measures, how to compute them, or what the formula looks like for it? That's kind of an unfair question because you're like me, the computer knows how to do it, so let it do it.
FYI's issue with the slides I posted this morning. We'll get that fixed here shortly.
Okay.
Pay attention to what Mark's doing.
Pay attention to what I'm doing?
Yeah, just keep your eyes focused straight ahead. We'll get it fixed.
Okay, so correlation. So we have two random variables. And that's my x1, x2, let's say we go down to xn. So that's the sample, and y1, y2, down to yn. Those are my samples. And my correlation between x and y, so if I call all of that x, and I call all of that y, the correlation between those two is calculated inside R by doing the following. It does x1 minus its mean times y1 minus its sample mean. And it does that all the way out to xn minus x bar, yn minus y bar. So it's just taking the difference between the observation and its sample mean for both the X and the Y and adding them up. And then that then gets divided by the following: x1 minus x bar squared plus dot 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 xn minus x bar squared. Any idea what this is computing? Say the variance, because all I'm doing is I'm gonna divide by the square root of the variance, which is the standard deviation, to normalize things to be between -1 and +1. So I'm gonna take that, and I'm gonna take the square root of that, and then I'm going to multiply that by y1 by squared plus dot 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 yn minus y bar squared, and then take the square root of that. And this is what's referred to as a Pearson measure of correlation. And that is the default for this. That's the default that you get in this. Now, you can do this with weighting. In this case, it's 1/n is the weight, where every observation is getting equal weight in terms of 1/n. There's other ways to weight it differently, where you might say, oh, the first observation is more representative of the population, so we put more weight on it, and then that weighting is going to be adjusted. But for right now, don't worry about that. Just think about it in this context. So, when I think about it with our FINRA data, what level of financial satisfaction would one have, and how is it related to the financial risk that that person takes? Any ideas? So if I'm satisfied with my financial conditions, would you be, Brianna?
I'd be more willing to take risks.
And what would that then mean for this relationship in terms of correlation?
It would be like positive.
It would be positive. Okay, so we expect that it's going to be somewhere between 0 and 1. It's kind of hard to say how strong that correlation is going to be, but that's kind of why we would do this. And then the next thing is to go ahead and start asking the question. How would you first try to answer that question? What would be a good way of, say, you're making an argument around what Brianna just stated in her project? What would be helpful for the reader to understand that? Brianna?
Make a line plot.
You can do a line plot. You could do scatter plots like this. Okay. And that's visual. People are visual people. They like to see things. They like to be able to kind of touch and feel and see, and that's going to be very helpful to then, even from your standpoint as the researcher, to see if there's something there. Okay. And so that would probably be the first thing that I would do before I'd even run the command. So let me show you what I did a couple of days ago. So one of the economists here, a guy by the name of Indrajit, shared something with me, and some of the research that he's been doing, but it came out as a result of the following. Since June, the 10-year, the yield, the rate on the 10-year Treasury bill, note, bond, note, has gone up from say 3% almost to 5% since June. And that 10-year treasury note yield has a lot to tell us about how the economy or how people think the economy is going to do going forward. And he has been doing some interesting research on how that 10-year note yield differs from, say, the 2-year notes yield. And often we found out over time that that difference between the 10 and the 2-year yield note is very helpful and predictive of slowdowns in the economy and things like that. And he has developed a model where he is able to look at how firms decide whether or not to be hiring or to be firing. And that then leads into what we refer to as risk premia, which would cause those yields to change. And so I thought about that, and I knew that we were doing correlation today. And so I went ahead and said, oh, well, that's a good example. So I'll just show you how we do things. So I decided, well, I'm gonna go ahead and plot what that 10 2-year difference is. And then, maybe I'm not doing exactly the same way as Interjet, but let's just go ahead and see how that compares from a correlation standpoint with unemployment. Because you'd expect that unemployment does what during a recession? It goes up. And during an expansion, things are going well, we'd expect unemployment to go down, right? Where is unemployment today? High, low? Is it tight, loose? It's real tight. At least that's what people tell me. So there's a website called Fred. It's out of St. Louis. It has a ton of data on it. And I'm just going to type in 10-year Treasury spread to 2-year and hit return. And here it is. See, 10-year minus 2-year Treasury constant maturity yields. That's exactly what I want. So I press that, and lo and behold, here is that spread, that difference between the 10 and 2-year Treasury note. And you can see that in this case, it's only going back to 2019. So let me show you the entire series. Now, do you know what these little gray bars are?
Like when things happen, like the grade.
These are NBER, which is the National Bureau of Economic Analysis, dated recession periods. So we had a very, very short-lived recession during COVID, very large one during the financial crisis, and then previous to that, you had some in the 80s and some in the 90s, 2000. Okay. And so you can kind of see what was going on with the yield curve, but notice every time just prior to these gray periods, if I go back to the ones that I can really see, what do you know about the difference between the 10 and the 2-year? Here's 0. Here's where that difference is positive, and here's where the difference is negative. All you're seeing in the last 1, 2, 3, 4, 5 recessions that the difference between the 10 and 2 gets negative. So the 2 gets above the 10. That's what happens. The 2-year is, and that doesn't make a lot of sense because there's probably more risk over the long run over the 10-year period as opposed to a 2-year period. And so there's, so if we look at today, it's very negative. So there's a lot of concern that, hey, it's so negative. We've seen in negative periods before that a recession was going to happen. So why wouldn't we expect the same thing to happen today? Okay. So that's why this measure is so closely followed and talked about among kind of financial prognosticators and things like that. And so I wanted to see how that was correlated with unemployment. So I'm going to come over here and I can just add a line And the nice thing about Fred is I don't need to know a lot. I just need to know what I'm, kind of in the ballpark. Unemployment rate. And I can see that it's got an unemployment rate here, and so I'm gonna add that series and see how that thing looks. And instead of going back all the way to, 1945, unemployment didn't show up until, latter part of the 70s, well, at least in this measure. So if, I think it was Brianna said, look, you could use, or Taylor told us that, hey, just plot these things. And here are two line graphs of the two things that I am interested in. Are they correlated?
Yes.
And what led you to say that, Taylor?
The shape of the unemployment line kind of follows the same pattern of the treasury.
Yeah, they may be shifted, but when one goes up, the other one's pretty well going up. When one changes direction, the other one changes direction, right? Okay. Now, if I just gave you what would you say this?
It's not enough information.
I mean, you got this guy trending up, and this guy's pretty well flat, right? Maybe a little bit here. But on that period of time, maybe not as strongly correlated, right? So, I then went ahead and said, oh, the nice thing about this, I can come over here, I can go to download, hit CSV file, and it will go ahead and give me a zip file with the CSV contents of both of these series. And where is it? Lost my
Pause it,
no, it's up.
you have a tab right next to it. Go back to the last one you're on.
There it is, sorry. So let me show you what I did. So I went in and downloaded those. I then uploaded them into our cloud. And I then read it into R. And that's what, here's my reading in, fredgraph.csv. I then, because one series went out to 1945 and the other one kind of started late 70s, I decided, I'm only interested in this series from 1980 going forward. So I used my filter command where I just wanted to take those observations that had a date that was 1980 or later. Okay. I then piped that into mutate because the original series had NAs in it, so I thought it was a string, and I need numerical values for correlation to work. So I changed them to numerical values here. Just to clean up things, I tell it to drop any of the NAs. And then I'm gonna go ahead and take that new data frame that I created, and I'm gonna plot it in a scatter plot, okay? And that's what I get right here. And don't worry about typing in all of that. We'll post that so that you can look at it. I mean, can run it yourself. So if you look at this thing here, the scatter plot, And that's over that entire 1980 to 2020, 3 period. What are you led to conclude? Taylor, are you still gonna, you're still saying that they're correlated?
No. Well, just these mini dots in this section.
I mean, you got a lot of dots. Now, sure, you got dots out here that maybe just, strays. But if I look at this, what is my eye telling me?
It's positive.
Positive.
That there's some kind of, when one goes up, the other one seems to be going up too. Maybe not as much, 1 to 1, but it's still pretty close. So go ahead and run the correlation, see what it does, what it actually is. Let me squeeze that, bring this over. And so I come here to this line here, and I'm going to go ahead and just execute that one line. And this calculated for that data. Is there, where's my pointer? There it is 0.4335. Does that seem reasonable, given what you've seen thus far? It's halfway between, not quite halfway between 0 and 1. It's positive. That's kind of what you told me from the very beginning, is that it was positive.
Right.
Are they perfectly correlated? No, that's why we had all that crap that was hanging out at the top, right? I mean, if you think about it, that's what, the reason why you're not getting perfectly correlated is you got all this stuff out here. But in here, it's clearly giving and leading to this positive relationship, right? Is that, Taylor, did you have a question?
No.
Okay. So we're not gonna do it here, but what hypothesis would you possibly think about performing on this? Hypothesis test.
A two-sided, independent.
So two-sided, in some ways we're thinking about 2 samples here. Because you've got unemployment in the difference, the spread in the yield. But the hypothesis explicitly would be, is this greater than 0? Or, and in my case, I think it's greater than 0, so that would be my null. That would be my alternative, and my null would be that this is less than 0. And there's actual ways to perform that test. All right, so that's making it real. I hope that's what you walk away thinking here, is that, oh, well, this is just not something abstract. This is actually something that one can do on the fly every day if they have a particular economic question. Now, let me go back to the causality question. Do you think that unemployed workers are making investment decisions on buying or selling treasuries? So do you think there's a causal statement between unemployment and the yields in the treasury market? It just happens to be that they line up. There's something else going on there. So you would never, I would, if I was doing this as my term project, I would not come in and say, oh, that 10 to 2 year difference is correlated with unemployment at 0.4. And that means that people that are unemployed are changing their investment behaviors as a result of being unemployed, or they then, sell more treasuries and buy less. Can't make that connection. That would be a causal statement where all we're doing here is statistical. Now, if we wanted to get after the causal, that's something that economists are really good at doing, but we need a different tool in our tool kit or our toolbox to do that. All right. So this is the case with the financial risk and satisfaction. You see that it's positively correlated. It's less, it's not as strong as the relationship as what I showed you between the treasury yields and the unemployment rate. But again, it's positive, so you have that. This is where I was talking about the weights, but I don't really want to get into that at this point. All that would mean is I would be coming in here and instead of 1/n being assigned to each of the observations, I would vary that 1/n. Some would get more weight, some would get less weight, but in the end, they would have to add up to 1 in terms of the weights. You can do that with this little command here where the FINRA data actually has these weights to make it. But in this case, the weighted version is not that different than the unweighted version. So not a little difference between what the sample is telling you and what they think the population would be telling you. Okay, as I said, this is the Pearson. That's the default. This is the default method that it uses. X could be a data frame, but that data frame has to only consist of numerical values. In the case here, in my example, if I put in the data frame, the problem I would have is I've got dates. And so it would say, hey, I only run if X is just numerical values. And since your data frame includes dates, and even though these are numerical values, it would come back and give me an error. Now, if I just simply created a data frame with the treasury, yield differences and the unemployment rate, then it would work. So you don't have to use a Y here, but you would have to have numerical values in that X. Extra credit question. Does that data frame, is it limited to only 2 series? In other words, this, or could I expand it to have 3, 4, 5 series? Yeah, because what it's going to do is it's going to look at each of those numerical series and do these calculations relative to each other pairwise. So as long as it's a numerical data frame, you're good. That's kind of what we said here, what we talked about there. Okay. And this is grabbing 3 in this case, 2, and then piping it into the correlation command. And there's another way where we could have 3 or even more series, as long as they're all numerical and calculated there. So why would you want to use the correlation measure? Can you think of something in your current project that might be relevant to this question? I kind of spelled it out with regards to mine, why I was interested in looking at these 2 series of the difference in the 10 and 2 years yield and then unemployment. So think about it for you in your project and how that might be. And then how could it save you time? Ooh, Taylor, you're looking at entrepreneurial stuff. What do you think leads to more entrepreneurs? I may be off base, but is there something where you'd like to know if one is related to another in your data set?
Yeah, well, a couple things, but one, like, race and industry.
Good. Could I just do a scatter plot around that, look at it, see if there's any relationship? That would be a quick, easy way to not waste time on a relationship that doesn't exist, right? So it's a way to save time to kind of validate your original thoughts. If they're independent, meaning they're completely just random, then it probably doesn't make any sense to pursue that. But I doubt that's the case in Taylor's case, in Taylor's project, because, you know, that seems like a relationship that would exist, okay? You do that before you like do a lot of regressions and other things. It's another way that you can just check your data. If Taylor didn't find that relationship, I'd be surprised. And then I would start asking myself, is there something wrong with the data set? Do I got missing observations, or are there things in there that are contaminated? Are there, you know, NAs, or there are these other NAs that they use minus 99999.99? All of that could lead me to say, you know, I've got something going wrong in my data. I need to go back and take a closer look at that. All right, so just to finish off this section on correlation, using that FINRA data set, can you calculate the correlation between their satisfaction with their financial condition, their willingness to take a risk, and we've already kind of showed that. But in addition to the correlations between those two, how those are also correlated or not correlated with how much they have if they have too much debt. Okay. So we'll do that, and whenever you're done, we'll take, feel free to go ahead and take a break, okay?
Yeah, the fresh slides are up, by the way. I uploaded the original lecture slides, not the
Mine.
fall
Oh, you didn't-
23.
The
Yeah,
fall of 2023.
Physically cannot.
good a lot. All right, so for the folks playing along at home, we're gonna do a real quick example of how to manage some workflow between an R script and an R markdown file. I think Mark went over this earlier. The R markdown file, think of it as being nothing more than a fancy Word document, plus it can do some other stuff, right? So in Word, we can paste directly in stuff from Excel and other applications, right? And we can even manipulate things, right, to some extent in a Word doc or a PowerPoint or something like that, right? But for the most part, right, if you're working in Excel, your work is going to stay in Excel, right? And you're just going to paste in sort of the results of that work into that document. You're in that exact same kind of mental state when you're dealing with an R markdown file. We can still manipulate data in our markdown file. We can show kind of what our work, so to speak, right, with our code in our markdown file. But really what's important is using the R markdown file to distill our results in these project updates, right? We can have a separate R script that shows all the heavy lifting we're doing and all the data scrubbing, everything else we've got. We can really reserve the R markdown file for just getting to the brass tacks of our analysis. So in this particular case, right, we've got a bunch of stuff here. We've grabbed some data off of Fred. We did a little bit of cleanup here in lines 8 through 11. Here, let's forget that for a second. And then we went ahead and did a plot, right? And so let's say for just example here that I just wanna go ahead and run this plot, right? In an R markdown file. So what I would do is.
So, in other words, how do you display the plot?
Yeah, I need to split, yeah, how do I get this beautiful plot?
In your project.
Right, in front. So what I wanna do is I need to save this to something, right? So I'm gonna assign it to, do this,
Scatter.
Right, so I'm gonna trade it, this to Trez scatter. Right, so if I look at my environment, I got a new object, right? It's called Trez scatter. If you get an environment that's really cluttered, you've got a ton of stuff going on, and you're kind of lost, or you're coming back to work later and you sort of forgot what you were doing a little bit. An easy way to tell what's a plot and what's not a plot is plots almost always have this list 9. Right? If you see this list of 9, that's a GG plot. Easy way to tell. So what we can do now is I can save. File equals plot.r. Alright, so do you guys understand what's going on in line 22? Right, so I've got an object here, Trez scatter, which is the plot I just made, and I want to save it to a file called plot.r. Right, R data is kind of a standard kind of file extension for saved R files. You can save as much stuff into these as you want. So if I wanted to, I could do Trez scatter, I could do df, whatever. I could just keep adding commas, right? I can add as much stuff as I want to with this. It will save all of that into an R data file. But for this example right now, I just want to save this Trez scatter. I run that and it saves. If I go to my files, right? I got this plot.r data, my directory now. So let's go ahead and start up a markdown file. You can still pick, sure, why not? Let's do example author, and I want as a PDF. Okay. So all of this. And if you remember in our intro here to should have Tidyverse. Let's go ahead and actually just mark Tidyverse. Tidyverse will have, should have just about everything in there. Let's make sure that runs. Let's see, it says. Yep, so
See how he's not.
just want to make sure, I just want to make sure.
Just always, just run it, just because he could have typed library wrong, he could have typed tidyverse wrong.
Tidyverse might not have been installed,
It
so it's gonna
just-
die on me, right?
Just
Go little by little.
little by little,
Right.
make sure things run. Don't get overwhelmed, don't be in a hurry.
Wait, can you do what you just did again? How did you get that
A
already?
little bit of woo-woo.
Yeah.
So you see this thing up here? You can insert a code chunk. So
Oh.
hit the drop down, it gives me a bunch of options for stuff. The one I want is R. Right, so I can Drek, if you're really fancy later on, you can enter in bash, which is like a command prompt, so you can do things like show what's in your directory.
Good catch, Brianna.
Yeah, Python.
Don't let him slip things up.
Dude, I'm slippery, you gotta look out. RCPP, which if you guys have taken like an intro to computer science class and you did C++ as your language, you can actually use C++ in R, right, to do some kind of cool stuff. Stan, which is a modeling language that Mark and I are very familiar with. But right now we're just gonna do R. And I think was it Command or Control Shift I think is the, something like that, right? You can do that as well as the hotkey. So I wanna load, right, the data I just saved. So let us save it as plots. And what did I say that as? Trez scatter. See what that does. Right. So what happened? Right? So I
How
have,
fast and easy that was?
see, so what happened? What happened? Let's go through the workflow real quick, again, one more time, right? So I talked to my economist and we're gonna work with this really neat data. However, it's like a gig, right? That's a lot of data. And you're having to come to us to increase your memory allocation. And you've got a bunch of data issues you're running through, and you've got this gigantic script, right, to get your data, this gig of data, to something that you can start running analysis on, right? The first thing you wanna do is generate a plot, a table, something that can kind of give context, right, to what you're using. So you can do all that in your R script here, right? And that's a lot of work you do. You put weeks into this work. Do I want to show all of that in an R Markdown file? When the question being asked is,
Show me a table.
give me a summary table of your key variables, right? Do I need to, what do I want to show? I really just need to show, right, the table, right? Do I care about the work? A little bit, right? Like as an instructor, I want to make sure you're doing the right thing. I mean, that's important to me, but for the sake of this document, no, it's not relevant.
For your project report,
Yeah.
it's not relevant.
It's not relevant. Like for your project report, like unless you're doing something unbelievably cool, right? That is like, hey, I came up with this neat little hack to figure something out, or this is unconventional and I just want to walk you through the code that I'm running, just so you're going to have, like, there are occasions where you're doing work and you know you're gonna get hammered with questions about what you did. Or you're using data in such a way that is not normal, and you know you're gonna get hammered on questions around what you're doing with the data. Then you can show your hand a little bit and show some of the code, right? And that's where doing those code chunks where we say E value is false, right? We wanna show the code, we don't wanna run the code. That's important, but for this 9 times out of 10, we just wanna show the results. It's okay to have everything running in your R script here, save out your results as an R data file, come back over to your markdown, load it in, and show your results. And here we're using a plot. You can do tables. It can even be, you've got millions of rows of data, and now it's something that's like tens of rows, hundreds of rows, maybe a couple thousand rows. And for the sake of expediency, right, it might actually be easier just to do that in R Markdown, right? You can, but you've taken something big that is hard to do, and you've made it smaller and simpler and lighter, and then you can move it over to R Markdown and begin to do some of your work there. If you're worried about showing your work or what the kind of necessary deliverable is, typically what we do in these situations that you're not just handing in like a PDF, you're handing in a PDF and a script along with it that shows sort of how you got to all these different figures, right? So you'd have like a section where it's like, you know, it's very common, actually almost standard, right? You have a section where you've done something and then generates figure 1.1 and 1.2 in
Hey,
R Markdown.
for,
in PDF. Right?
so in my code, go ahead and use ggplot. You can actually just cut and paste to do a time series plot of that, of the treasuries,
Sure.
so that Leah can see it.
I'm gonna change this to, I'm gonna clean this all up. We're gonna do this live, figure 1, I'll call this figure 1.1. Right, and points plus W, because that's how I roll. Gonna do labs, title equals
Scatter plot.
Treasury term spread versus unemployment rates. Right, and because I don't know what this is, subtitle equals
Right.
1982 current. Right? So figure 2. DF spread on lots. That's x equals 8, y equals, you want the
Either or,
t,
you could do them both.
can't do 2.
You need to see.
I'm gonna do this, I'm gonna blow your guys' minds. I'm gonna leave my aesthetics blank for right now. And this is gonna be kind of a sneak peek into the advanced plotting stuff later on. But this pipe that we have here is automatically gonna fill out the data section in ggplot for us, right? So what I can do here is now add different geometry. So I'm gonna do geoline. Yes. Dates y equals T10 y 2, is that right? Is that what we're calling?
It's uppercase 2y.
2y. Color equals spread. Those unrates colored. You guys familiar with line width? Line width allows you to adjust the thickness of your line. So I think ggplot defaults like 0.5 or 0.75. Sometimes that's okay, but whenever you're plotting things like a big plot, right? You want those to be kind of nice and thick. It's just kind of makes them stand out, makes them pop. So I'm gonna do that here. So get that plus MBW, again, that's how I roll. Let's go ahead and do labs, title equals. Title equals 1980. Let's add some axis letters. Is that T10Y2Y is kind of vague, right? I know what that means. You might know what that means, but does your reader know what that means? Maybe not, right? So let's go and make this clear. Let's do treasury. Spread y equals. Great. So x is easy, right? X is just gonna be the date, right? Do I think I need to put a label for date? It's kind of obvious, maybe, right? So maybe we can leave date blank, right? You can also use themes. Axis.title.x will delete the axis title, right? So it'll actually expand the size of your plot a little bit. It's kind of like literally deleting the axis title here. It just puts a blank space in the title, so there's still space in your chart for the. Right? It's an aesthetic thing. When you start doing this enough, they matter. It's like a little kind of craftsman kind of stuff. For Y, what do you think we want to call this? What do we have here? Is it called percent? So maybe I'll put percent on the side. Am I confident of that? I don't know. Let's look. Yeah, which one are we looking at? Spread. Okay, so these are whole numbers, right? So these are whole number percents and not decimalized, right? So. Figure 2. And let's go and save. Figure 1, figure 2. Saves it up there. Let's go back over here. Example 1.
Need to, in your junk. Really great. Tell it to, not show the commands.
You understand why I'm doing message equals false? So sometimes our functions are what we call verbose, they're pretty chatty, they give us a lot of description about what they're doing. It's not throwing an error, it's not throwing a warning, it's just being very descriptive. I just don't want those to show in my, when I do this markdown. So I'll put message equals false, and so that will suppress whatever messages have. Yes.
So on my homework, I was getting a message, and then like in the R file, it put show underscore column or something, and then equals false. But when I put it in my R chunk setup, it still ran the message.
Yeah, there's probably like, it's eval equals false. No, not eval, it's echo equals false, message equals false, warnings equals false. Like, there's like 4 or 5 different options you can toggle, and where that comes from is that in R, there's a function called try catch. And what try catch does is it will evaluate your command, and then it will say, if it generates an error, do this. If it generates a warning, do this. Otherwise, show this output, right? And so you kind of have to sometimes like mess around with a bunch of, figure out sort of which one it's throwing at you. And you may have like your little header inside the curly brace may have just like a ton of options in there that like, you just may throw everything in there just because you don't know what's gonna hit with you, and you just aren't, like, you don't have time to. I have some where it's like 2 lines of options and stuff that are in there. Let's go figure 1.1. Okay, and let's copy that. And let's do figure 2. I don't need to load plots. So I'm doing that. Top. I already loaded my data at the very beginning, so I can clean this up. Is this going to run? In effect,
So it's not gonna run without the little curly things, I mean, the things inside of the curly parentheses, like the image?
sorry, can you say that one more time?
It's not gonna run without the echo false, message equals false.
It'll run, but it'll show all the kind of coding work on the back end.
Okay.
And
It'll show
so,
you how it, almost like what comes out in the R console.
Okay.
And you don't want that in your output for your project or your project updates in most times. Because all you're trying to do is, what does the reader need to know?
So
Yeah,
So the time series
mine
is
always
like
has
one.
everything.
so here's our original plot, right? Here's our time series.
So it should look like that.
Does that make sense?
Yeah.
Lynn?
Yeah, when I did mine, well, I didn't do an R markdown, but it didn't even pop up as a figure. It just kind of
I mean-
a lot of words.
Run it in R.
Mhm.
So Brian didn't run anything,
Oh, yeah, I just saved everything,
he
yeah.
just saved everything,
Well,
so
yeah.
we've never even seen a run in
Yeah.
R. I wouldn't do it that way,
Yeah,
I would make sure R ran
so here's,
gave
here's
me
our
what I
first
wanted.
figure, right?
before I would save it to a .r data file. Because otherwise, I don't know if it even has what I wanted.
So here's your first figure, and then we've got figure 1.2.
Like, when I do that, it doesn't pop up.
What,
It's like-
Doesn't,
do you have dates in it? I mean, does that data frame have the date in it?
It says
Year. See, it's got year for,
is it a date structure?
no, it's a cross section, so. She's got year and then you've got banks,
Mhm.
so. I'm not sure what
You want
she's
to say that?
asking for a time series plot of, because. You can tell that if I just take a particular bank ID.
Mhm.
And I group by bank ID. Then it would work, because each bank is gonna have a time series for the
Well,
variable that you're after.
okay, so, year, I'm assuming is just numeric. So what you could do is, remember we did with Labor Day, we did like YMD. You do a YMD truncated equals 2, and that'll force us into just a year date type. And then, so you can then plot on your x-axis this year variable. You know, I'll show you on the big screen, like kind of what you do. So you've got some data here, right?
Mhm.
Let me just start a new one. So you've got some data. Right. Yeah, that's good. Like, you know, library, Fediverse, and library. Right, so you got Library loaded, you got your data, you do like a mutate, like year equals YMD, year trunk equals 2, right? So that's going to take your, that year, that 4-digit year, and it's gonna put it into like a date variable type, and it should show like January 1st or something like that, right? It should, I'm not certain if it's going to suppress all of that when you plot it out. So these may be like year-end values as opposed to year begin values.
Mhm.
That's a different discussion. We're not gonna worry about that right now. But once you've done that, you can then type it into ggplot. Because you have a lot of these bank IDs in there,
Mhm.
if you are plotting the data for a single bank ID, then you can do something like a line. In this particular case, because you have a bunch of bank IDs, I'm not sure how many you have. I'm guessing it's a lot.
Yeah.
So what you can do is, because you have a lot of bank IDs and you kind of want a time series, you can do a G on points. Right?
Mhm.
And you just do x equals your, in this case, it was year, y equals, I don't know what your variable is, right?
Mhm.
And what it should show you is something, you know, years along the x-axis, right? Y-axis is gonna be whatever the scale is for that particular variable. I'm not sure what it is, whatever you're trying to show. But instead of showing lines, right, you're just gonna have just a sea of points. It's gonna look like a scatter plot,
Mhm.
but instead of doing it, you know, like 2 sort of dependent variables, right? Or 2 independent variables, it's just gonna be data on the bottom, right?
Okay.
And you might, I don't know what you're gonna get out of that.
Mhm.
My guess is that that's gonna be your initial plot, and then you're probably gonna wanna group by I don't know,
Bank ID.
Hey,
not necessarily bank ID, but like, if she's got a lot of bank IDs, it's not gonna get her, I don't think it's gonna get you anywhere. You're probably gonna take those bank IDs and you're gonna summarize them by like asset size or maybe take like an average, right? So you'll take like the average something, right, per year.
Yeah.
And then you can do a G online, right? Like G onlines work really well if you have like one variable that you're trying to plot.
Yeah, I think
If you've got a
yeah,
lot
that's
of,
the part that I don't understand that Camelia is asking you. She's asking for a time series plot, but I don't know what she wants a plot of.
now,
And if you've got a cross section in your data, which you do, because you have time and you have bank. So you've got 2 dimensions there. That it doesn't make any sense there to do a time series plot. Because you have to, you know, is it a summary or is that an average of all the banks? That's the part I'm not quite sure of, and so you may
So-
want to talk to Euritzy or Camelia about what's the variable she's after, and then just to explain, well, time series plot for all of the banks or just, you know, a summary of the banks or whatever.
so at the beginning of the semester, we talked, I've kind of said this too at points, I don't know if everyone together or just individually. But the value as an analyst, wherever you are, isn't really on how sophisticated, you know, if you're reporting or, although that is valuable, the real, where the rubber meets the road with all this is on the data, right? Because you're in the data so much, you know in your head sort of what these things look like. So a community comes to you and says, give me a time series of something, and your brain just grinds to a halt. He's like, that's impossible. That's like divide by 0. Like, I don't know what you're doing. And so when I get that question a lot, and Mark will ask me like, hey, Brian, can you give me a plot of this? What, if I'm getting refs and NAs in my head, I'll come back to Mark and say, so in your head, what do you think this plot's gonna look like, right? So, and say like, are you thinking it's gonna be like a scatter plot? You think like a line, a bar? Like, what do you think in your head this is gonna look like? Because he knows what he's asking for, and it makes sense to him. It doesn't, like, we're not speaking the same language. We're looking at the same data, we're coming to very different conclusions. And so, and then he'll say, no, like, I want a line chart times, like, it should look like this. And then you're gonna go, well, hold on a second, I've got like 1,000 bank IDs. I'm not gonna plot 1,000 of these things. It's gonna be, like, I could, and
But
it'll
it's-
run, but it's gonna look like a hot mess, because it's just gonna be, it's gonna look like a bundle of knotted string, right? It's gonna look like grandmother's yarn basket. And so you can kind of come back and say like, oh, well, should I group by firm size? Do you have like, should I average these somehow? And you know, what she was originally thinking might have been, well, oh, I wanted like an average of something, or like give me 2 or 3 of the biggest banks, or give me 5 at random, or something like that, right? And that's, you know, by being in the data as much as you guys are, right? Like that's kind of, because sometimes like, you know, the economists you're working with, they're familiar with the data, they kind of got a good understanding, right? But the questions may have been poorly formed, or they may, you know, their head is just in some other place, like than where the data currently is, right? So maybe they thought that the step was ahead or behind, or that they, you know, they thought that question seemed reasonable for the data, but, right? You can kind of step and say, yeah, we can't get that far.
So, any questions about the R markdown stuff? Does that make sense,
I have a question.
Brianna?
So I know you said like we know if this list of 9, it's always going to be of 9.
Yeah,
See how
so,
every figure, because those are the attributes,
yeah.
so.
So if I do a little drop down here, right, it's gonna have data, and then it'll have scales, it'll have theme, mapping, et cetera, et cetera, et cetera.
Just
Those are
this
the
the
categories.
structure.
Yeah, this is, so when ggplot generates a figure, right, it's always gonna have those elements to it.
Yeah.
So,
So I have a question. So who
has not been able to complete project update 2 because their data still isn't read in and functional.
I know we understood yours, we got
2.
But
Okay,
I was gonna do
what
it.
about project update 3?
I have my project update 3 done, but I can't get into it. I can't save it because my R.
Okay, so let's work on that, Brian, and Dion. We can just work with you now for the next half hour.
Let me just say one last thing about these charts, right? So this is up to you. I prefer to keep things in the script and then move it over to our markdown, but sometimes you're gonna be handed stuff that is just sort of not quite ready for prime time, and you're not gonna have the underlying data to recreate it, right? So you're just kind of working with what you got. So let's say in this particular example, somebody handed you this file called plot.r data, and when you needed everything, it generated these 2 particular plots. They're not bad plots, but are they great plots? Could they be better? Yes, they could, absolutely. These would actually, but a hot mess, if you were going to do it, you would have annotated a little bit more clearly kind of what the axes were and things like that. And so where it does make sense in some cases to do the work in R Markdown is that if you notice little things, you gotta make some quick edits to your document. You can keep adding to these plots. So these are ggplot objects, right? So it doesn't really matter when you start them. If they're kind of already rendered, you can then go back into them and start manipulating different things. So in this case, like labs. So you do x equals, what do we call that? Here, spread. Play. Right, you can do that. And then figure 2 looks okay, but like this color thing, and then it's in the British spelling of color, which doubly annoys me. Let's go ahead and fix that. Title equals blank. And then let's say that I just don't like that legend being outside of the chart here, right? It kind of throws off the whole aesthetic of my document. I want to put it someplace else. I can do something with the legend dot position. And legend position goes from 0 to 1, 0 to 1 x, 0 to 1 y. So I'm going to put it roughly about a quarter of the way over from the left. And I'm going to put it almost all the way up to the top. Let's go 0.5. Is that going to work? Perhaps. You want to go over farther? Maybe somewhere around the. I'm aiming for like this point here. I want to put my legend kind of right there. Think that'll work. Yeah. There we go.
Nice.
Right, so I've cleaned up my axis here, right? After I've already rendered it in my R script and I've saved it, pass it to R Markdown. I can still do edits to it in R Markdown. And then the same in here. Right? So kind of clean this thing up quite a bit.
Okay,
So
all right. So I think Dion,
yes,
see where things are at with Dion's
you guys.
data. And then Shavai, I don't know. But Taylor, you're good. Grounded, you're,
Yeah, I'm good.
I mean, I know I saw yours, so.
Yeah.
So it looks like things are on track there.
Yeah, it's much better.
Leah, things good?
Can I go see David?
Yeah,
Yeah, please.
Taylor?
So my project update 3, like project update 4 is like the same way, but like with the, I guess a better presentation of it. But mine was not, I got an understanding of it this week of like what I'm supposed to be doing. So, I mean, I turned it in, but I don't have to go back and resubmit. Just turn it in.
No, you're good.
Okay.